There's a theory circulating in certain corners of the internet that sounds completely insane the first time you hear it. It says that mountains are not mountains. It says that what we call mountains, Everest, Denali, the Rockies, the Himalayas, are actually the petrified stumps of trees so massive they make our entire modern world look like a toy set. Trees that once stood 40 miles high, trees that were alive, trees that were cut down or killed by something we have not been told about, and the forests they belong to once covered the entire surface of the earth. If you have ever looked at a flat-topped mountain and felt something was off, stay with us. If you want to go down every rabbit hole we uncover here, subscribe right now. We post the deep cuts that other channels skip. The modern version of this theory exploded in roughly 2018. That is when a YouTube channel called Mud Fossil University, run by a man named Roger Spurr, started posting videos claiming that geological formations were not rocks at all, but biological tissue. Fossilized flesh, organs, and trees from creatures and plants of incomprehensible size. Spurr's videos pulled millions of views. He pointed at rock formations in places like Moab, Utah, and said those canyon walls were the petrified skin of giants. He looked at mesas and said flat tops meant cuts, not erosion. Around the same time, a separate wave of content began focusing specifically on trees. The claim was simple and visual. Look at a basalt column formation, like the ones at Devil's Postpile National Monument in California, or the Giant's Causeway in County Antrim, Northern Ireland. Those hexagonal columns, the theory said, are not cooled lava. They are the cross-sections of petrified tree trunks. The six-sided geometry is not a product of thermal contraction. It is cellular. It is biological. It is wood. The theory then scaled up. If those small columns were trees, what about larger formations? What about buttes? What about the flat-topped mountains called mesas across the American Southwest? What about Shiprock in New Mexico, that enormous volcanic neck rising 1,745 feet from the desert floor? The theory said Shiprock is a stump, a dead, petrified stump of a tree so old and so large that it stopped making sense as a tree the moment you looked at it. And then the theory went all the way. Silicon, which makes up a huge percentage of Earth's crust, is also the primary component of plant cell walls in certain organisms. The silica content in rocks, the theory argued, is not geological, it is biological. The entire crust of the Earth is a graveyard. The whole planet is made of dead things we no longer recognize as living. Now, before we spend any more time in that world, let us ground ourselves in what science actually knows, because science knows a tremendous amount, and some of it is genuinely strange. The tallest tree alive on Earth right now is a coastal redwood named Hyperion, located somewhere in Redwood National Park in Northern California. It was measured precisely in 2006 by naturalists Chris Atkins and Michael Taylor at 380.3 feet tall. That is roughly 116 meters. That is the tallest living thing we have confirmed exists today. The tallest tree in the fossil record was a species called Prototaxites. This is real. This is not a conspiracy. Prototaxites lived during the Devonian period, roughly 420 million years ago, and it stood about 27 feet tall, or about 8 meters. Compared to modern redwoods, it was tiny. It was also not technically a tree. Most paleobotanists now classify Prototaxites as a giant fungus, or possibly a rolled mat of liverworts. The debate ran for over 150 years after the Swiss paleobotanist Ludwig Buxenschutz first described the fossils in 1855. During the Carboniferous period, 350 million years ago, forests of lepidodendron trees covered enormous stretches of what is now Europe and North America. Lepidodendron grew to about 160 feet tall, or roughly 49 meters. That is real. Those were real trees that were genuinely massive. Their stumps are preserved in places like the Fossil Grove in Victoria Park, Glasgow, Scotland, where 13 upright stumps were discovered in 1887 during quarrying operations. Those stumps are still there. You can visit them. So the Earth did have much larger trees in the past. That part is documentably true. The jump from 160 feet to 40 miles, which would be 211,000 feet, is the jump that requires extraordinary evidence. 40 miles. Now let us just sit with that number. The cruising altitude of a commercial airplane is roughly 35,000 feet. A 40-mile tall tree would extend to approximately 211,000 feet. That is nearly 6 times the altitude at which planes fly. At that height, you are well into the mesosphere. The atmospheric pressure at the top of such a tree would be effectively zero. Liquid water cannot exist at those conditions. The mechanisms by which trees transport water, xylem, phloem, osmotic pressure, operate within specific physical limits that collapse long before you reach even a fraction of that height. The tallest any theoretical tree could grow, given atmospheric pressure and the physics of water transport, is estimated by botanists at around 400 feet, or roughly 122 meters. Nature appears to have confirmed this independently, since no living tree has exceeded that ceiling. But people who push the giant tree theory do not accept the physics as settled. They argue that the physics only apply to our current atmosphere. They argue that before whatever catastrophe destroyed the ancient forests, the Earth's atmosphere was denser. Gravity may have been different. The magnetic field may have been stronger. There may have been a canopy structure in the upper atmosphere. A firmament, some say, that created a pressurized greenhouse environment across the entire planet, allowing biology to operate at scales we cannot imagine today. Some of them point to the Carboniferous rainforest collapse, which is a real event. Around 307 million years ago, the vast tropical rainforests of the Carboniferous period fragmented rapidly across what is now Europe and North America. Temperatures shifted, the forests collapsed into isolated pockets. The event is documented in coal seam records. Scientists have studied it extensively. The giant tree theory people ask, what if that collapse was not climate change? What if it was something else? What if the collapse was caused by something that also left the planet looking the way it looks today? This is where the theory gets its emotional power. It does not just claim trees were big. It claims something happened. Something was lost. Something was taken. And the mountains are the tombstones. Let us look at mesas specifically, because they are the strongest visual argument the theory has. A mesa is a flat-topped elevated landform with steep sides. The word comes from the Spanish word for table. The Colorado Plateau in the American Southwest contains hundreds of them. Monument Valley, which straddles the Arizona-Utah border, is one of the most photographed landscapes on Earth. The Mittens, Merrick Butte, the formations rise straight up from the desert floor, their tops flat and level, their sides nearly vertical. The standard geological explanation is called differential erosion. The tops of mesas are capped by hard rock, usually sandstone or limestone, that resists erosion better than the softer rock beneath. Wind, water, and time wear away the surrounding material, leaving the harder cap elevated and isolated. The flat top is explained by horizontal sedimentary layering. The rock was deposited in flat layers millions of years ago, and erosion simply reveals the geometry that was always there. The giant tree people look at the same formations and say, or they were always flat on top because the top is where the tree was cut. They look at the vertical sides and note that trees have vertical sides. They point out that the ratio of height to width in many buttes and mesas is similar to the ratio of height to width in tree trunks. They point to the fact that many of these formations contain silicified wood, actual fossilized wood, and argue this is evidence that the entire formation was once organic. The Petrified Forest National Park in Arizona actually contains real petrified wood, 225 million-year-old logs turned to stone, scattered across the desert floor. Some of those logs are over 9 feet in diameter. Scientists explain them as trees that fell into rivers, were buried in sediment, and had their organic material slowly replaced by silica-bearing groundwater over millions of years. The giant tree people point at those logs and say, if those small trees petrified, why couldn't larger ones? It is a fair rhetorical question. The science answer is that, yes, petrification can occur at larger scales, but the process we observe always results in the replacement of organic material by inorganic mineral, cell by cell. A 40-mile-tall structure would require an almost unimaginable volume of silica replacement over an almost unimaginable timescale. There is no mechanism that produces that at planetary scale without leaving unmistakable geochemical signatures. And here is where the theory meets its hardest wall. Mountains have roots. This is not a metaphor. It is a documented geological phenomenon called isostasy, first described quantitatively by British surveyor George Airy in 1855. When mountain ranges form, their mass depresses the crust beneath them. The Himalayas, which began forming around 50 million years ago when the Indian subcontinent collided with the Eurasian plate, have crustal roots extending approximately 75 kilometers beneath the surface. Those roots are detectable with seismology. We can measure them. We know they are there because earthquake waves travel differently through thicker crust than thin crust, and those differences match the predicted root depths with extraordinary precision. A petrified stump sitting on the surface would not produce those roots. The internal structure of mountains, the folded, compressed, metamorphosed rock you find when you drill into them or examine road cuts through them, shows the mechanical history of tectonic collision. The rock inside a mountain has been subjected to pressures and temperatures consistent with being buried kilometers deep and then uplifted over millions of years. You cannot fake that record in the rock. The minerals themselves record the temperatures they experienced through what geochemists call thermochronology. Zircon crystals found in mountain cores contain uranium and thorium that decay to lead at known rates. Geologists use these decay ratios to date when specific rocks cooled below certain temperatures, which tells them when those rocks were at specific depths and when they were uplifted. The data from the Rockies, the Alps, the Andes It all paints a consistent picture of tectonic uplift over tens of millions of years. There is no zircon clock that shows a biological origin. This is also the right moment to address shiprock directly, because it appears in almost every version of the giant tree theory. Shiprock, called Sebita-i in Navajo, meaning rock with wings, is a volcanic neck. It formed when magma intruded into the surrounding sedimentary rock roughly 27 million years ago. The softer sedimentary rock eroded away. The harder, igneous rock remained. Geologists can identify it as igneous rock, not just visually, but chemically. It is maminette, a type of potassic, igneous rock. Its composition matches other known volcanic necks. There is no ambiguity here in the geological record. The giant tree theorists often say scientists are lying, or that the classification system is itself the cover-up. This is the unfalsifiable wall that separates the theory from science. If every piece of contradictory evidence can be dismissed as part of the deception, the theory becomes immune to disproof. And immunity to disproof is not a strength. It is the definition of pseudoscience. But let us not dismiss the human hunger behind the theory too quickly, because there is something real underneath it. People feel lied to. They feel that the official story about history, geology, and biology has been simplified to the point of falsification. And in some areas, they are right. The Younger Dryas impact hypothesis, first formally proposed in a paper published in the Proceedings of the National Academy of Sciences in 2007 by a team including researcher James Kennett, argues that a comet or asteroid fragmentation event around 12,900 years ago triggered a massive climate shift, wiped out the North American megafauna, and destroyed early human civilizations. That hypothesis was initially mocked. It is now taken seriously by a growing number of researchers and has been supported by the discovery of a platinum-rich layer in sediments at dozens of sites across 3 continents, including a site at Abu Huraira in Syria, where evidence of extreme heat consistent with an impact event has been found in the record. Things have been wiped out. Catastrophes have happened. The official geological story has been revised before, and it will be revised again. That part is real. The leap from there to 40-mile trees and mountain stumps is a leap the evidence does not support. But the instinct that says something big happened and the full story has not been told is not crazy. It is, in fact, the instinct that drives good science. The electric universe theorists, the catastrophism researchers, the people following the work of the late geologist J. Harlan Bretz, who spent decades arguing that the channeled scablands of eastern Washington state were carved by a catastrophic flood before the scientific establishment finally accepted he was right in 1979. These are people who pushed against consensus and sometimes won. Bretz was born in 1882 and died in 1981, 98 years old, and he lived to see his catastrophic flood hypothesis vindicated. The Missoula floods, which carved those scablands, are now accepted as real. A wall of water 500 feet high traveling at 65 miles per hour. Real. Accepted. Once mocked. So the pattern is real. Science resists. Science sometimes resists things that are true. But there is a difference between Bretz's hypothesis, which was built on field observation, physical evidence, and falsifiable predictions, and a theory that requires a global conspiracy of every geologist, every physicist, every chemist who has ever analyzed a rock. The giant tree theory, when pressed to its logical conclusion, requires that radiometric dating is fake, that plate tectonics is fabricated, that the entire field of seismology is either wrong or a lie, that crystallographic chemistry cannot distinguish biological from geological silica, and that thousands of scientists across 2 centuries in dozens of countries have all collaborated to hide the fact that mountains are stumps. The coordination required for that cover-up would be the most impressive achievement in human history, more impressive, arguably, than the trees themselves. What this theory actually reveals is a deep and genuine desire for the world to be more extraordinary than we have been told. People look at the Grand Canyon and feel something that a geology textbook does not satisfy. They look at Yosemite's Half Dome and feel the presence of something ancient and incomprehensible. They are not wrong to feel that. Half Dome is real granite that was intruded as magma into the Earth's crust roughly 87 million years ago, slowly cooled, uplifted, and then had 3/4 of it sheared away by glaciers during the last ice age, which ended roughly 11,700 years ago. That is an extraordinary story. That is a true story. And it requires no trees. The silicon connection, the observation that silica is abundant both in rock and in certain biological organisms, is real chemistry deployed in a misleading direction. Diatoms, radiolaria, and certain sponges do build silica structures. The glassy shells of diatoms can preserve in sediment for hundreds of millions of years. There are entire rock formations, called diatomites, made almost entirely of compressed diatom shells. The Lompoc diatomite deposit in Santa Barbara County, California, is one of the most commercially significant in the world. So yes, biology makes rock. Yes, rock can be biological in origin. The leap to mountains being tree stumps requires far more than biological silica chemistry. The final and perhaps most damaging fact for the giant tree theory is the oxygen record. Trees produce oxygen through photosynthesis. A forest of trees with a combined biomass equivalent to all Earth's mountains would have produced oxygen at a rate that our atmospheric record, preserved in ice cores, ancient air bubbles, and isotope ratios in ancient rock, does not reflect. The Carboniferous, when the largest ancient forests actually existed, did have elevated oxygen, around 35% compared to today's 21%. That spike is why giant insects were possible. Dragonflies with wingspans of over 2 feet, like Meganuptera monii, which lived roughly 300 million years ago. The oxygen record is consistent with big forests. It is not consistent with a biosphere so massive that it would dwarf all current geological formations combined. There is one final thing that almost nobody mentions when they tell this story. In 1985, in a sandstone formation in the Gilboa region of New York State, paleobotanists discovered the oldest known fossil forest. The site is called Gilboa, and its trees, called Eospermatopterus, lived approximately 385 million years ago. In 2019, researchers including William Stein of Binghamton University published new analysis in Current Biology showing these trees were far more complex internally than previously understood. Their root systems spread across an area equivalent to multiple city blocks. Their internal structure showed branching complexity that suggested they were not simple plants, but sophisticated organisms responding to competitive forest dynamics. 385 million years ago, trees were already playing a long game, already competing, already building structures engineered by millions of years of pressure. That is real. That happened. The Earth has hosted extraordinary biology, and we have only begun to recover its record. The mountains are not stumps, but something extraordinary was here before us, something we have barely begun to understand. And the people looking up at flat-topped mesas at sunset and feeling the scale of lost time are not entirely wrong to wonder. The rock remembers. We just haven't learned to read all of it yet.